Hello everyone. This is my second class. Okay, this is my next class of electricity and magnetism. In this class, this is a lecture 22 class. So in this class, I will define you magnetic flux, electromagnetic induction, first law, second law, electric field, motional EMF, linear motion, rotational motion, and energy stored in inductor. Okay, so this is our electromagnetic induction. Okay, so magnetic flux. So by which way we will define magnetic flux? So I will not define you, I will give you only mathematical formula. So when a magnetic field occur on a body on a unit area, then the how many flux will comes from that body, that is called magnetic flux. So it you can see from this figure, this is a circuit, and this is the direction of magnetic field, and this is the direction of area. So the angle is theta. So magnetic flux is v dot a, that is a uniform v, and for non-uniform magnetic field, phi v is equals to closed integral v dot dA. Okay, and phi v is equal to b dot a is equals to ba cos theta. So when theta is equal to 0, then magnetic field is parallel to vector a. Then phi v is equals to ba. When magnetic field is perpendicular to vector a, then theta is equals to 90. Then phi v is equals to ba cos 90. That will become 0. Okay, so when phi v is equals to ba, then b is equals to phi v upon a. That is called magnetic induction, and it is also called magnetic flux density. And we will discuss unit in SI. Its unit is Weber, and in CGS Paditi its unit is Maxwell. So 1 Weber is equals to 10 to the power 8 Maxwell. Okay, now we are discussing about electromagnetic induction. So this is the circuit. So when there is no battery, but when a magnet comes near to the circuit, then electromagnetic field produce, then phi b will become change, means flux is change. So it will depend on potential difference that will produce induced EMF, current that will produce induced current I. So if circuit is open, then I is equals to 0, and I is equals to E upon R, and we know that E is not equals to 0, then I will become 0, then R will come infinite. Okay, so now we will study first law of electromagnetic induction, and we will also know it by the name of Newman's law. So it is E is equals to minus ka del phi upon del t. E is equals to minus ka n del phi upon del t, and it will become minus ka del n phi upon del t. If del t tends to 0, it will become minus ka n del phi upon del t, and denote the number of turns, and phi flux linkage. Now we will discuss you second law, Lenz's law. So it's defined induced current always oppose the cause due to which it created, based on energy conservation. Okay, so this is a circuit, and in it there is a no battery, and it is a magnet. When a magnet comes near this circuit, then electromagnetic field it changes. So that's why current will increase. So when it comes near the circuit, there is two cases when it come near the circuit and when it go far from the circuit. So this is the second case. So there is a two direction. One is anti-clockwise and second is clockwise. So we will show the direction of current in this way. Okay, now E is equals to minus current del phi upon del t. I is equals to E upon R minus n upon R del phi upon del t. Q is equals to I delta t, that is equals to minus n upon R del phi. Now we will discuss electric field. So del V is equals to W upon Q. There is a circuit from A to B and B to A. So W is equals to Q dot del V, and we will define W by closed integral F dot dl, because there is a zero potential difference. That's why F is equals to QE, closed integral QE dl is equals to 0, and we will define closed integral E dot dl is equals to 0. That is Stokes law. And closed integral d dot E dA is equals to 0 means del cross E is equals to 0. That is E, that is a conservative field created by charge Q. And here E is equals to minus del V upon del. Electric field created by a magnetic moving magnet, that is delta phi V, is equals to minus del phi upon del t. And when we will put closed integral E dot dl is equals to all these things, phi V is equals to del V upon del t, and because due to A we will note del cross is equal to this, and after all the things we will find out del cross E is equals to minus ka del V upon del t. This is for non-conservative, and this is a magnetic third law. Now we will study motional EMF. First of all we will study linear motion. So this is our charge carrying conductor. When it moves from B in direction B, and if a charge produced from positive to negative, then magnetic field work in inward direction. Okay, so Fm is equals to minus ka QVB sin theta when it is produced in this. So Fm is equals to Q minus ka QVB sin theta, that is equals to QB, and F is equals to QE. So in equilibrium F is equals to Fm. So we will put all these things here. We will find out V upon L is equals to VV. So V is equals to VVL. Here this is the potential, this is a velocity. So potential is equals to velocity into magnetic field into length. So motional EMF is equals to capital V is equals to VVL sin theta. Theta is angle between V and V. If theta is equals to 0, then V will become 0. That is, motional EMF is produced only when the conductor cuts the field line. Okay, so this is our velocity, and it is our horizontal and vertical coefficient. Vertical is V sin theta, and horizontal is V sin theta. Horizontal is also defined by magnetic field. Okay, now we are discussing rotational motion. So this is our charge carrying conductor, and its length is L, and there is a magnetic field in inward direction. Then the E will become 1 by 2 V omega L square. And so this is for a vertical, this is for a rectangular shape, and when we will describe a disk, then E is equals to 1 by 2 V omega R square. And now we are studying energy stored in inductor. So 0 to I naught, 5 is equals to there is a circuit, it is a battery, and it is a switch. So when a current flow it, a magnetic field will produce in it, and this will current here comes here. So 5V is change, and EMI induce EMF. Due to induced current produced, and I naught is steady maximum current, and the energy stored in inductor is U is equals to 1 by 2 L I naught square. Okay, so this is for in this class, and I will discuss things in next class also. Thank you.